Hi everyone, happy Friday. Hopefully for those of you who are newer students to K-12 Florida Online School, you were able to take your NWEA testing and hopefully you didn't have any tech issues. So this video is in lieu of those Class Connect sessions because as you guys noticed, you didn't have a whole group or a small group for today, so Friday the 25th. So this video is a replacement of that. So we are going to cover OMHS 1.11 and 1.12, which is continuing with scientific notation. We're going to work on multiplying and dividing, and then going into problem solving. Now, just like before, we need to make sure we are always in that habit of completing the OMHS lessons first. So if you haven't gone into OMHS, so that's your main page where all of your classes are, you need to go to Content and complete both 1.11 and 1.12 first. Then come back and watch this video, okay? So the learning target for today is that you can use operations, so in this case, specifically multiplication and division, to solve problems that are with and written in scientific notation. So on Wednesday, we talked about what scientific notation is and how to add and subtract. So today we're going to follow up with that and multiply and divide. All right, but before we do that, we are going to briefly review exponents. So exponents is what we learned last week. So when you multiply powers, what operation is performed to the exponents? Subtraction, addition, multiplication, or division? So if you don't know the answer, take a moment and pause the video so you can think of it or go back and find it in your notes before I reveal the answer to you. It is addition. So if you notice that you have two powers being multiplied together and they have the same base, you can simplify them by adding the exponents. All right, same question, only this time we are going to divide the powers. So if you're dividing the powers, what operation do you perform on the exponents? All right, with this one, they're very much related. So if when we multiply, we add, what do you think we do when we divide? We subtract. All right, now that we've reviewed that, let's get into how we multiply in scientific notation. Just realized my camera might be in the way of the problem, so let me move that up. All right, there we go. So if we have two 2 75 hundredths times 10 to the negative eighth, and then that is multiplied by 4 6/10 times 10 to the negative third. So here, both of these are expressed in scientific notation. And as a brief little refresh, remember with scientific notation, that is the one time we're allowed to use an X for multiplication. And it always has a base of 10 because that is how our number system is built, is in a base of 10, because you go ones, tens, hundreds, thousands. They're all multiples of 10. So our very first step is we want to group our number terms together and then our power of 10 terms. So our number terms in this case are both of our decimals. So 2 75 hundredths. And it's still being multiplied. I'm just rearranging them so that way they're grouped together and I can visualize it a little bit better. Times 4 to the 6th. And then I still have my scientific notation, X here. And then we're grouping our power of 10 terms. So 10 to the negative eighth, 10 to the negative third. So all we did was just rearrange it so they like terms could be together. All right, we're going to start off by multiplying our power of 10 terms. And I like to start with doing this first because it's the quickest. So right here, do we have two different powers with the same base being multiplied? Yeah. So that's why we had to learn about the rules of exponents first, because the rules of exponents say that if you are multiplying like powers, you add the exponents. So -8 plus -3 is -11. So this stayed the same, but now I have simplified my power of 10 terms. All right, now we can multiply our number terms. Now this takes us back with multiplying decimals to elementary school, and it maybe has been a little while since you've done that. So when we multiply decimals, remember that we always want the number that is longer and has the most digits on top. So my 2 75/100 is not larger in value. Like if we think about it as money, $2.75 is not more than $4.60. But when we're multiplying, we put the longer one, so the one with more digits on top. And then with multiplication, you do not have to line up the decimals. So now you just go ahead and you kind of temporarily ignore the decimal and you go through and do your standard multiplication. And when you do that, you need to make sure to correctly place that decimal point. So I'm gonna put a little something here. So when you did that multiplication and you added everything up, you should have gotten a 0 right here. And how we know where to put our decimal point is we tally them up. So there are 2 numbers after the decimal here, 1 number after the decimal here. So 2 plus 1 is 3. So that means I need to move my decimal up 3 places. So 1, 2, 3. That's why we placed it right there. And then remember, when we're multiplying or when we're working with decimals, unless we're talking about money, if we have zeros on the end, we don't need them. So that's why when this first came up, you just saw 12 65/100. All right, let me go back here so I can switch. See, whenever I write, it never wants to change slides for me. There we go. All right, so all we have done here is we've now just combined the two. So we simplified our number terms and got 12 65/100. In step 2, we simplified our power of 10 terms and we got 10 to the -11th. So we've rewritten it. Now, sometimes you can be done. Other times, we maybe need to rewrite it into proper scientific notation. Because if we look at this is not proper scientific notation. Because we learned on Wednesday that with scientific notation, the number in front of the decimal needs to fall between 1 and 9. And is 12 between 1 and 9? Heck no, it's 3 more. So I'm going to need to move my decimal and rewrite this in proper scientific notation. Come on, move slides, please. There we go. So in order to move this to proper scientific notation, I am going to move it up 1 spot. So therefore, if I move my decimal up 1 spot, I need to add 1 to my exponent. Because remember, your exponent tells you how many times you moved the decimal. So if I have to move it up once to rewrite it, that means I need to add 1 to my exponent. So here we have our final answer written in proper scientific notation. 1 265,000th times 10 to the -10 power. All right, I know that was a mouthful, but a lot of that was us trying to go back and review some stuff Wednesday in case you guys still had some questions on that. But really, just to kind of summarize it, when you multiply in scientific notation, we're taking 2 things you've already learned, multiplying decimals, and then multiplying exponents, and just merging them. All right, let's do a practice problem here. So sea level at the Battery, so Battery Park. Oh, let me clear this here so we don't have all my drawings. Is rising by about 2.84 times 10 to the negative third meters per year. Yikes. At this rate, how much will the sea level rise in 20 years? Express your answer in scientific notation. So, this is one that I encourage everyone to pause the video for and on your notebook that you should have next to you, or maybe it's a folder with paper, that you try this problem out yourself. And you can always rewind the video and watch that previous example or look at your other notes. But try to solve this one on your own first before you watch me go over it, okay? All right, hopefully that gave you guys enough time to pause. So let's move forward. All right, first we need to make sure our problem is set up properly. So if you guys want to double check things along the way, you could pause the video intermittently. I could give you the steps on here and then you pause it and perform the action yourself if you've decided to keep hitting play because you're a little unsure. So we know that it's rising. So we want to know how much it's going to be in 20 years. So we need to take 20 years and multiply that by how much the sea level is rising by. But if it wants us to express our answer in scientific notation, that means both of my numbers need to be written in scientific notation. So we need to rewrite 20 in scientific notation. So this also refreshes what we did on Monday, not on Monday, on Wednesday. All right, so the way we do that, if you guys recall, is we need to move up our decimal point. So it goes right here, so 2. And then how many times did we have to move the decimal? Only 1 time. So normally we wouldn't write 20 in scientific notation, but in order to do the math, we need to. So now that both of our numbers are in scientific notation, we're going to follow those steps we talked about earlier. So let's group our number terms together and our power of 10 terms together. So our 2 number terms, our 2 power of 10 terms. All right. The next step is let's go ahead and simplify our power of 10 terms first, because that's a little faster. What do we do when we notice that 2 of the powers with the same base are being multiplied? How do we simplify that? We add the exponents. So positive 1 plus negative 3 is a negative 2. All right, now that that's simplified, we need to multiply 2 times 2.84. All right, when you guys set this up, which number needs to be first? Which number needs to be on top? Hopefully you said 2.84, because that, when we multiply, we want the number with the most amount of digits, so my longest number, to be on top. And then after you finish multiplying, remember to place your decimal point properly. So this 2 doesn't have any decimal points. This number has 2 after the decimal point, so when you're finished, you need to move that decimal point 2 times. And you should get 5.68 times 10 to the negative 2. Now, is this one in proper scientific notation? Yeah, it is, because 5 falls between 1 and 9. So because of that, I don't have to do any extra steps at the end. This is my answer. So in 20 years, in Battery Park, New York City, the sea level will have risen, will be higher by 5.68 times 10 to the negative 2 meters. All right, we're going to go through division. The nice thing is these steps with the division are honestly the same. The only difference is instead of multiplying, we're dividing. But all those other steps about grouping things, the order in which we work, it's pretty similar. So hopefully, now that you guys have seen a couple examples, this one will start to click a little bit more and make more sense for you. All right, so just like before, we want to group our number terms together and our power of 10 terms together. And in case you guys haven't picked up on this yet, now that you're in middle school, and especially now that we're in 8th grade pre-algebra, 99% of the time, if you see division, it's going to be written as a fraction. We don't usually use the division symbol anymore. And actually, fun little fact for you, because this is one of my favorite facts. Let me switch to the drawing tool. So the reason that this is our division symbol is it actually is a fraction. So the two little dots on top and below represent numbers in the numerator and denominator. We just, whoever, I don't remember who created it, they used the dots there instead of variables to show that that's what division means. So really, even when you use this division symbol, you're really using a fraction. Fun little tidbit for the day. So my fun little tidbit was about how the division symbol was created. All right, let's go back to the problem. So now that they're grouped, just like before, we want to simplify our power of 10 terms first. So here, if we think back to our rules of exponents, when you are dividing powers that have like bases, these both have a base of 10, check. We subtract our exponents. So 9 minus 3 is 6. All right, let's divide those number terms. So just a couple reminders here in case it's been a little bit since you've done long division like this. Remember that your numerator is what goes inside of your divisor bar, and your denominator is what you are dividing by. Okay, because it's 4 8/10 divided by 3. So the 3 is on the outside, the 4 8/10 is the dividend on the inside. Here, when it comes to dividing with decimals, you're allowed to have decimals on the inside, just not by what you're dividing by. But in this case, you don't have to worry about that. So you can just bring your decimal point straight up and then do long division like normal. Once you finish that division, you will have 1 6/10. Now let's rewrite our answer in scientific notation. Let's do a double check here. Is this answer good written as is? Yep, because my 1 here falls between 1 and 9, so it's written in proper scientific notation. I'm good to go. All right, we have one final example that we're going to work on together. So the average distance from the Earth to the moon, okay, so Earth to the moon, is about 3 8/10 times 10 to the 5th kilometers. Now the average distance from the Earth to the sun is about 1 49/100 times 10 to the 8th kilometers. How many times greater is the distance from the Earth to the sun than the Earth to the moon? So the first thing we should do, so if you guys already know what to do, go ahead and pause the video and practice this on your own. If you're a little stumped on where to start, watch the next little bit with me and I'll help you get started, and then you can pause the video and try to finish it on your own. So when I look back at this, one strategy that I always use when I come across word problems is called the 3-read strategy. So I've already read it once. That first time of reading is just to get the gist. My second time of reading is to find the important information. So I'm going to read this again, and I'm going to underline the important information. So the average distance from the Earth to the moon is about 3 8/10 times 10 to the 5th kilometers. So I'm going to even put E to m up there, so I remember that's Earth to Moon. And then the average distance from the Earth to the Sun is 1 49/100 times 10 to the 8th kilometers. So E to S. Now I want to know, here's my question, how many times greater? So I'm going to circle that. How many times greater? And we'll just have to close off our circles. Is the distance from the Earth to the Sun than from the Earth to the Moon? So it says Sun than Moon. All right, that's a lot of information. So let's dissect that. First, let's start with our question. It wants to know how many times greater. So what operation do you guys think we need to do? And remember, your operations are adding, subtracting, multiplying, and dividing. You may think times because it says times, so multiplying, but if it wants to know how many times greater it is, we want to know that, so we need to do the opposite. So whenever you read something that says how many times greater is one thing than another, in order to figure that out, you have to do the opposite. So that means we need to divide. So now that we've accomplished and recognized division, with division, it's important to know which number is first, so which is our numerator and which is our denominator. Well, it tells us right here, I want to know how many times greater the sun is, the distance from the sun is, than the distance from the moon. So that means the sun goes first, that's our numerator. The moon goes second, that's our denominator. So when we set up our problem, it should look like such. So here's our distance from the sun divided by the distance from the moon. So that by doing this division, we will discover how many times greater that is. All right, if you guys stuck with me there and you have not solved it on your own first, now that we've talked about how to set it up, go ahead and pause and try this on your own. Okay, now that you guys are back, let's double check our work here. So the first thing we need to do is split it up, group our number terms together, our power of 10 terms together. Now let's simplify our power of 10 terms. So we have powers with the same base being divided. So what do we do to our exponents? We subtract. So it becomes 10 to the third. 8 minus 5 is 3. Now we are ready to simplify our number term. So here when we simplify, we will need to make sure to move our decimal points because we cannot have a decimal point in our divisor. So when you divide, you should have 0 and 392 thousandths times 10 to the third power. So is this right here in proper scientific notation? No, it's not, because our value here, our coefficient, is 0 point something. And that does not fall between 1 and 9. So I need to convert this to proper scientific notation. So which way do I need to move my decimal point this time? Do I need to move it to the left, so forward, or to the right, backwards? I gotta move it backwards. So when you move it forwards, you're adding a decimal point. If you move it to the right, so you move it backwards, you're subtracting a decimal point. So that means when we move it one spot to the right, we have to take 1 away from our exponent, because our exponent is how many times you move the decimal, and we just took one of those movements away. So here we have our final answer. Now, this is where at the beginning I was talking about that 3 reads. If you notice, we only read it twice. The third read is after we're done to make sure we fully answered the question and to find the label that we need to include in our answer. So if I go back and I'm just going to specifically read the question, how many times greater is the distance from the Earth to the sun than from the Earth to the moon? All right, is that what I did? Yep, I divided. So then when it comes to labeling my answer, the distance from the Earth to the Sun is 3 and 92 hundredths times 10 to the 2 kilometers greater than the Earth to the Moon. Now, that was a mouthful. Whew. But that's okay. All right, guys, just a couple reminders because we are on Friday here. We're at the end of the week. So for those of you that have been with us from the beginning, so you had in the past these 3 OMHS assignments. All of this was on Exponents, and then these 3 IXL assignments. So hopefully all of this is done. Now, for students that just started with us this week, you probably don't have an IXL account yet. So don't worry about the IXL assignments, but do please go back and do the OMHS one, because as you found in this video, we used something from prior lessons. So what I've done to help you, because I know you're not starting at the same time, I don't want you to be overwhelmed, is I'm just asking you to focus on the OMHS only and not the IXL. And that's just for our kids that started this week. Everybody else needs to have the IXL done. So if you're sitting here thinking, Mrs. Ailstock, should I do the IXL or not? Well, if you see that the IXL is exempted, that means you don't have to do it. If you see that the IXL is either graded or empty, you need to do it. And one thing that I will be doing is on Monday, I will be putting missing zeros in for incomplete IXL assignments. So anybody that has completed it, I've given you guys a grade. Anybody that hasn't, I've continued to leave it blank, but on Monday that will change. So please make sure, for those of you guys that have been here for a couple weeks and you have not done your IXL yet, please go back and do that. All right, here in blue is the due this week. So since you're watching this video, that means all 4 of these OMHS assignments should already be done, because you're supposed to watch those before the videos, before the live session. So these 4 should be checked off. And then your IXL assignments might actually already be done too, because the only 2 IXL assignments you had for this week are what went with Wednesday's lesson. There is no IXL that specifically goes to today's. And then lastly, as I've been talking about, but I know some of you guys maybe haven't seen it in the live sessions, we do need to be spending 15 minutes in the diagnostic arena. So that's 15 minutes for math and 15 minutes for ELA. So in total, 30 minutes a week. Now you get to choose how you do that. You can do all 30 at once and then you're done. Or maybe you do want to split it up and just do a little bit at a time, okay? And just so you know, the reason it's kind of grouped together like that, so in total 30 minutes, is because it will go back and forth between math and ELA questions, all right? So as always, guys, if you have any questions, please email me. But also remember that on Monday at 4 o'clock, I have my office hours. So if you have questions about the assignments, if you have questions about the math, because maybe you've been doing all of the work and you're still a little confused, which is fine, because I know that we haven't had our normal schedule yet, then you can come and we can do some practice problems. I can help you out. So any questions you have, email me, come to those office hours Monday at 4, and I'll help you out because I want you guys to be successful. All right, now, as I've done with my other videos, if you guys watched the whole thing, to get a bonus point, what you need to do is email me the fun little fact that I shared with you. And if you're not remembering the fun little fact, I'll give you a hint. It has to do with, all right, have a good weekend, guys. And if I don't see you Friday in small groups, then I will see you guys Monday in office hours, and for sure Wednesday in our normal class connects. Bye.